right, let's start with this test review. I'm going to go over sample exam 1A for test 1. So this is the first exam in your course packet that's after all the test 1 materials. So it's after the chapter 6 normal distribution stuff. Okay, so we'll spend about 15 minutes on each video, and hopefully at some point we'll finish. So we'll start on the first page. Which of the following is not a measure of variation? So we learned measures of variation and measures of center. And measures of center point out where the center of a variable is, whereas measures of variation quantify how consistent or spread out the data are. The three measures of variation that we discussed are the range, that's the min minus, the max minus the min. The IQR, that measures the range of the middle 50%. We take Q3 minus Q1. And the standard deviation. And the one that's not a measure of variation then is C, the mid-range. The mid-range is the max plus the min divided by 2. The next question wants us to identify what sampling method is used. And that's what that diagram to the right there is. I'm kind of trying to draw it as well as discuss it. So we have selected 500 drivers under 30 years of age and then 500 drivers over. So the researcher split the data up into two groups, over 30 and under 30. And then within each group, he took a random sample, those should just be dots, of 500. So he didn't survey everyone within each group, but he went to both groups, which would be every group, and took a random sample. So the idea with the stratified is that you split the data up into groups, and within a group you take a random sample, and you also go to every group. In this case there's only 2 groups, but the researcher hit up every group. If we split the data up into, let's say, freshmen, sophomore, juniors, seniors, then we would go to each grade and take a random sample. So the next question, we're doing the same thing. A researcher selects 48 middle schools and interviews all the teachers. So a key word here is all within each group. And so the idea, I wasn't able to draw 48 groups here, but let's just pretend we have a few. The researcher is only going to pick a few of these. So maybe this is one school, but within a school, he'll survey everyone. So within a school, he surveys every person. So instead of taking a random sample like up here, with the cluster, you survey everyone. And maybe you only go to 2, but within each cluster, you survey everyone. So, all right, that didn't work at all, but I'm trying to fill in or color in between the lines. Okay, so here he went to one school, surveyed everyone within the school, and then another school, everyone within. And then he ended up going to 48, but this would be a cluster. The drawing's a little messy, but I think hopefully you get the idea. All right, the next question, the median of a data set for a variable is the data value that, and then you're given a lot of options here. So lies in the middle of the data when the data is arranged in ascending order. That is the median. So we can go ahead and circle that one. Oh, my pen won't go out that far. But the answer is A. The next one appears most often. That is actually the mode, not the median. Is the sum of the observations divided by the number. That's the mean. So C is describing the mean. And then the max plus the min divided by 2 is the mid-range. Sorry for my handwriting. In real life, it's actually quite a bit neater. Okay, so that's number 4. The answer is A. Go ahead and scroll down to number 5. In distributions that are skewed left, what is the relationship between the mean and the median? The mean will always get pulled toward the skewness. So if something's skewed left, the mean will get pulled toward the left. And so if we have a histogram that's skewed left, it's going to look something like this with the tail on the left-hand side. So these numbers could be outliers, and that affects the mean but not the median. And so the mean will always get pulled toward the tail. The median will stay fairly stable. And so for skewed left, we have the mean is less than the median. If we were looking at skewed right data, the mean would get pulled toward the right side of the tail, and so the mean would be higher than the median. All right, the next question wants you to identify whether something's a parameter or a statistic. And so keywords to look for, the word all usually, or entire, that would be a parameter. The parameter means that I'll just abbreviate it. A parameter means that you're collecting information from your entire population. And if you see something like survey, sample, or select, we'll just write sample here. Those are all clues that it's a statistic. All right, and so the first one I see after inspecting all of the 55,000 kilograms, so I see the word all. The inspector is looking at all the meat, so I'm thinking it's a parameter, and then we found that 45,000 kilograms of meat was spoiled. So since he went to all the meat, that would be a parameter. He would not eat there. 1,000 randomly selected adults were asked whether they drink at least 48 ounces of water. And so we didn't survey all adults, we randomly selected. And so that would mean that it's a statistic. Okay, the next question is to determine whether something is discrete or continuous. And the idea here is that if you have something that's discrete, you can only have whole integers. And so maybe you have 1 or 2 or 3 or 4, but you can't have something in between a 1 or a 2, or in between a 2 and a 3 or 4. We'll just put this to 8. And a continuous, so a discrete variable is limited to occur on the integers, 1, 2, 3, 4, so forth. A continuous is a measurement, so it can be anywhere on the number line. It could be right here, it could be right here, it could be anywhere. Whereas a discrete, it has to be a whole integer. Discrete, you're counting whole objects, whereas a continuous, you are measuring something. So discrete, think count, and continuous, think of a measurement like height or weight. All right, and so the total number of phone calls, a lot of times number, when you see the word number, that's a count. That might clue you in on that fact that it's discrete. And so he's total number of phone calls, that would have to be a whole integer. You can't make 1.35 phone calls, and so that's discrete. And height is a measurement of a 2-year-old maple, and so certainly that doesn't have to be a whole number, so that would be a continuous. Okay, so you see this is a count, counting the number of phone calls, whereas this is a measurement. I'm measuring a tree. Next one has to do with the normal distribution. Areas under the standard normal cannot be negative, whereas z-scores can be positive or negative. So that's true. We calculate negative z-scores all the time. The answer is A. Area is the same thing as the area of your house. That's what we mean by area. So areas can't be negative. Z-scores can be negative because you can have observations below the mean that would result in a negative z-score. All right, so let's move on to some normal distribution problems. The next two problems, actually the next 3 problems, we're going to be using the table or your calculator. Now these problems are standard normal, and so we can go right to the table. Clues or hints to look for, you want to note whether it's left or right. In between, those are things to look for. Also, if you're given a z-score, you want to find the area. If you're given the area, you want to find a z-score. And so those two things you want to get straight. Here we're given a z-score. And now I can either go to my table and look up 1.13. Here's all positive or negative. So I just go up to 1.1. That's right here. And 0.03. So 1.13 is right here. 0.8708. All right, so let's go back to the exam. 0.8708 is correct. And then if you like the calculator, no problem. We can do this on the calculator. So I can go to a second, VARS, normal CDF, hit enter. Now I need an upper bound and a lower bound. So if I want the area to the left, my lower bound is just going to be a large negative number. And then my upper bound is just 1.13. And then I can just hit enter. And I get 0.8708. Now notice I wanted the area to the left. If I wanted the area to the right, I would subtract from 1. And of course that answer is there as well, just to trick you, but you want to make sure you get this correct. If it's the area to the left, you don't have to subtract from 1. If it's the area to the right, you do. Okay, let's move on to the next one. Since I have the calculator handy, we'll do it on the calculator first. What is the area between negative 1.10 and negative 0.36? So I go to my calculator and do the normal CDF. And I put in negative 1.10 for my lower bound. And for my upper bound, I put in negative 0.36. And I get 0.2237, so that's C. Now, if I use the table, I can do it on my table as well by looking up those two numbers. I would take whatever I get for negative 0.36 and then subtract what I get for negative 1.10. So I can go to my table, go to negative 0.36. So here's negative 0.30, 1, 2, 3, 4, 5, 6. So I would take 0.3594, and then I would subtract from that negative 1.10. So I would take 0.3594 and then subtract 0.1357. Okay, and that would give me the same answer. A little more difficult if you use the calculator. I mean the table, sorry. Okay, so that's page 1. I'm going to cut this video off, and then on the next video we'll go over page 2. See you in a bit.